Let's go to the solution of the assignment. We'll go to our classroom, playlist, GNAI LLM scores. And then we are talking about assignment number 6. For you to reach assignment number 6, you have to complete nearly 8 videos. This is the assignment number 6. Video 8, part 3, that is the assignment explanation. Make sure that you go to the assignment explanation, make sure that you attempt that assignment, and then as a solution, you can go through this particular video. Now, this is a very interesting assignment. So this is known as talk to your code repository, interact with your GitHub repository. So the user input is GitHub repository. The user query related to the code, user can ask a code related question depending on that GitHub repository. The output should be retrieved code based on the user query. For example, if we give the input data as a scikit-learn GitHub repository, if we give this as input repository, if the user query is code for decision trees, then the output should look like this. The code for decision tree can be found in this, etc. So using the RAG technique, the RAG has to be built on this GitHub repository so that if the user asks a question and we have to answer it according to the question that the user has asked for. As of now, I will solve this problem. Maybe if time permits later on, I'll try to deploy this. I'll try to create a tool or a front-end UI where the user can enter the GitHub repository as well as ask a question. We can create a UI as well. But right now, we will try to create a RAG system. We'll try to solve this particular problem in this assignment. As usual, we will try to create a copy of this file. You also code along with me. Must observe a couple of minutes of video and then you try to code and then again watch the next snippet of the code and then try to code along. So first we'll start with packages. The packages are pip install LangChain, pip install LangChain, pip install OpenAI. ChromaDB is required later on. As of now, we do not need that, but anyway, it has suggested. Tick token is also required later on, that is while doing the embeddings. It is a LangChain community that is important. That is also required. LangChain _ community. Step 1 is clone the GitHub repository. We will try to get the GitHub repository. You can use repo.clone from GitHub repository for cloning the repository. The user can give the GitHub repository as the input. So what we will do is we have to use for cloning the GitHub repository, we need to use a package called git python. So I would say pip install git python. So previous packages are being installed. After them, we will go to installation of git python, and then we will try to take this particular piece of GitHub repository for importing, and then the questions will be asked on that particular repository. Installing. Successfully installed here. Let us get started. From git import repo. If there's any already existing local repository, you can remove that. Otherwise, you will say mkdir make directory local repository, local copy. So I'm creating a new folder here. So local repo copy. Generally, a safe way to write this code is if there is already an existing one. So remove local copy and create one more. By chance, if you're redoing it, sometimes it may throw an error that already it exists. So this is a safer way to write. So then we will write that repo URL, or let me call it as GitHub repository URL is equal to this one. This is the GitHub repository URL given. Once you have given the GitHub repository URL, so my repository is equal to repo.clone GitHub URL and then local repo, local copy repo. This is the one that I want to use. So whatever is there in this scikit-learn, that will be now copied into your local copy. As of now, the copying is still happening. Once it is copied, you will see your local copy here. Yes, it has been copied. Let's have a look at that. Let me refresh it. Refreshed, and then this is the local copy. Here is my local copy. In that, we are not going to use all these folders. We can actually use the local copy as well, but examples is the folder that we'll focus in this particular example. In this particular case study, we'll focus only one folder. Otherwise, we can usually give the complete folder as well. If you want to have a quick look at what are the particular files and folders, you can say import OS, and then print, yeah, os.list directory local repo. These are all the ones. So if you want to copy any of the folder names, then you can, or the file names that are there in the actual path of local copy repo, the ones that we have seen here, you can get a like subfolder names, subfile names, they will not appear, but the remaining ones will appear here. The ones that are there in the main document or the main folder, they will appear here. Now let's get into the RAG. We have the data ready. This is the data. Out of these, I would be loading only the Python code files. As of now, our focus is only, it's a talk to your repository RAG. So in that repository, we are focusing only on the Python code files and nothing else. So we will try to get such kind of document loader, which will do a wonderful job for Python code reading. So from LangChain document loaders, there is something called generic loader, and then there's something called language parser, and these are wonderful import loaders, especially if you want to parse JavaScript language or Java language, Python language. You can use these language parsers particularly. As of now, I will take only one particular folder, so our local repo path example folder, only I will try to take examples. So if you go here, there is one folder called examples. Let us copy the path, and then this is the folder that, only that single folder is what we are going to work with and nothing else. This is the only folder that we will be trying. I hope you can see this font. Then I would write my loader. This is little tricky. Try to focus on this. My, yeah, generic loader. So I would say my loader is equal to generic loader from file system, local repo example path folder. And then you would say my suffix is .python only. And then I would like to go through all the folders. All this is a regular expression that will try to search for all the folders, go to all the folders, all the subfolders, go everywhere within this examples folder, go for all the folders, all the subfolders, and with the suffix Python. So I think a better way to write this would be try to search Python files in the folder that I have given you. Not only that main folder, look for the subfolders as well. And my parser is language parser. And you can mention my language. The programming language that I'm talking about is Python. Python is the keyword here. Now, this is a particular way of taking Python. Usually when you are doing the uh, chunking later on, if it is a string, you can chunk it anyway. But if it is code file, Python code file, then the chunking will happen accordingly. The code will not be cut in a meaningful manner instead of cutting it at any place. For example, if you have import pandas as PD, definitely it will make sure that that PD will not be cut, or import pandas will not be in one chunk as PD in another chunk. That will not make any sense. But when we are telling and when we are informing the loader that we are loading Python files and you have to use this language parser. So this is specialized for not just string data, for language data. The data where you have the code files. If you have to deal with code files, you have to use these language parsers or generic parser where you want to access all the files and you want to access Python code files here. Documents equal to document loader. The length of the documents, how many documents do we have? Let us have a look at that. There are 493 documents available. Probably 493 code files are there in these examples. All small, large, all the files are 493 files are there in this examples folder. So once you load the data, split the document into chunks. All the instructions are given here, what you need to be using, etc., etc. Maximum enough hints that I have given. So you can try it first, and then only if you're not able to get it, then try to refer to this documentation. So let us try to split the data. Splitting is also a little tricky. There are 493 documents, so let us have each file size slightly larger. So from LangChain text splitter, import recursive text splitter. You can also use something called language. So let me write that separately. Like usually we use only recursive text splitter, but I would like to use from LangChain text splitters, the same thing. From LangChain dot text splitter import language. So you have to import language as well as recursive character text splitter, both of them, because we are going to do here the code text splitter. It's slightly different. Earlier we used to give chunk size and chunk overlap. This time we will also give the language that we are talking about. So my text splitter, code text splitter is recursive character text splitter from language. Earlier it used to be from documents. Now it is from language, or from file system. It used to be like this is from language. Chunk size you can maintain, like usually I feel that finally in the RAG you will get 4 chunks as the final output, and then summarize those 4 chunks of information to answer the final question. If the 4 chunks put together is forming 5000 tokens, so that is the overall limit of any large language model or OpenAI API. So the chunk size usually I keep it somewhere between 1000 to 3000, so that at the end when you are doing any query you can get sufficient number of chunks and then get a meaningful information. Usually the chunk size that I maintain is 1000 to 3000, looking at the final output usage. Chunk overlap 10% to 20% is what I maintain. And the language that has worked perfectly well for me until now. Language is Python. This is an important additional parameter that you must mention. So after this, we will say code splitter. And then I would say my code chunks, code underscore chunks, code text splitter, split the documents, give the documents as the input, all the code documents. If you want to know the length of code chunks, or if you want to simply print a couple of code chunks, that is also possible. Or code chunks 0, I think that would be better. Let me print the first chunk. So this is the length of code chunks. 899 code chunks have been created, taking the chunk size as 3000 character. Chunk overlap is 300. And what you are seeing here is the first code chunk, page content equal to this. Let's say if there are overall 899. So let me print the code chunk ID 500. So how does that look like? This is the ID 500. Like some part of the code, I think it looks like matplotlib code somewhere. If I try to get the 50th one, or the ID 50. This looks like some kind of classifier. It looks like accuracy calculation, decision boundary, display, estimation, etc., etc. These are all has been mentioned here. So we are done with importing the data. We are done with splitting the data into chunks. Now the next step is converting it into some kind of embeddings, and then storing them in a vector database. So the embeddings that we will use is OpenAI embeddings. In your case, if you do not have OpenAI, you can use Cohere trail key and then work with it. So when we're talking about OpenAI and Cohere, we must get those OpenAI API keys. So from google.colab, we should have done it earlier. Import user data, import OS. Anyway, OS has been done. That is OpenAI API key, and then OS dot environment. It's not SERP API, it is Cohere. I would say Cohere. API key is get Cohere. So you can use either OpenAI or Cohere, any one of these two. Grant permission. For you to grant permission, you have to make sure that in the secrets, you have to keep these with the same ID. You have to keep it. Otherwise, directly also you can write OpenAI API key equal to. In here, you can write it this way. Your key can be written like this. This is a safer way or a better way. So let us try to first create these embeddings. I just need to write one line of code for embedding. So from LangChain embeddings, OpenAI embeddings, and then from vector stores, ChromaDB or FizeDB, we can use any one of them. Import tick token, that is for embeddings. So I would say my embeddings equal to OpenAI embeddings, ChromaDB equal to Chroma from documents. Documents are code chunks. Let me write this. Documents are my code chunks. That is the first one. Embeddings are nothing but OpenAI embeddings. I can say my embeddings are equal. Embeddings is the keyword. Let's call that as, let me call it as code embeddings, so that we can distinguish both of them. Code embeddings. Embeddings is a keyword. Code embeddings is what we are storing it as. And then persistent directly, where I want to store this directory locally I would like to store it here in something called codedb, and then codedb dot persist. So what it'll do is it'll create a new database folder here locally. Local database will be created, Chroma database. So this is the one first. We have granted the permission anyway. And then let's go to the next line of code. So there's one error. That's good to get an error. Let us see. Embeddings, the keyword embeddings. I think it must be embedding if I think correctly. What is it? Embedding only? Yes, embedding. Once this is created, so it's getting created, definitely it's a quite a large file system. One of the reason why I have taken only examples folder is for this only. It was taking a hell lot of time if for larger number of files. So that is why I have taken that examples folder, which is itself is a bigger one. Now the Chroma database, vector database is created. It's time for us to do the retrieval and Q&A. So let us do the retrieval Q&A. This is ultimately, so the query would be code for decision trees. We should get the code for random forest, code for gradient descent. Let us get that. So from LangChain, dot chains import retrieval Q&A from LangChain dot we need LLM OpenAI as well. Retrieval with source chain, that is not required. Sometimes we can get the retrieval with source as well, but right now we will be interested in retrieval Q&A chain. So my retriever equal to my code DB as retriever. My large language model is OpenAI or Cohere, any one of them. So I would say my code repository or code repository Q&A is retrieval Q&A chain from chain type. And then I would say my large language model is large language model chain type is stuff. So all the output that has been retrieved, all the codes that have been retrieved, they will be stuffed together and sent to the retrieval Q&A chain for synthesizing the final answer. My retriever is nothing but this particular retriever based on the code database that we have created. So we're all ready with this one. The only thing that is left is asking a query. My query is equal to what is the code for decision trees, and write code repo.qa.run. So this is the output. Maybe it's a smart idea to store the output in the result and then try to print the result so that we can read the output very well. What is the code for decision trees? There you go with the example: x equal to iris data, y equal to iris data dot target, x train, y train, x test, y test, and then CLF decision tree classifier, max leaf nodes, random state equal to 0. Perfect code. This code create decision tree classifier. Again, the accuracy of this depends on what is the large language model that you're using. If the large language model is Cohere, maybe you may not be getting this much accurate result. That's what I have observed. Now let's do one more example. The same thing, instead of code for decision tree, let me call it as code for random forest. Code for random forest. Code for random forest is this one. aria.fit. The last one we will try. You can try. Again, the accuracy of this depends on how much data we are giving. Like if we are asking a question that is not there in the repository of files that we have given the RAG system, then we may not get accurate results, or we may get the output saying, I don't know the answer. Code for gradient boosting. Code for gradient boosting. I'm not sure code for gradient boosting, it says. Maybe gradient boosting code was not there. Let me try to say code for XGB. XGB. I'm sorry, it may not have XGB code. Let me get it. Again, depends on whether the code was present in that repository or not. Code for regression. Code for logistic regression. It looks like it has it, but it is not able to generate and give us. Let us try it a couple of times unless until we get it. It says that the code for logistic regression can be found somewhere, but it is not giving. As of now, it gives log regression or detailed code for logistic regression with examples. Let's write it this way. Looks like it is hallucinating. It is trying to give us the answers that are from the internet. Looks like not from, like, it is getting the output from the RAG, but while it is synthesizing the final answer, it is trying to get it from all the over the places. Again, it depends on whether the repository that we have trained, or the repository that we have given it to RAG, does it have all the files or not. Right now, I have taken only these examples. Within these examples, whatever are here, those are the ones that we will get the output. So maybe we will say code for model selection or model validation. A code is provided model validation, decision tree threshold, maximize this. It is trying to give us whatever is the best option. So this is just an example of how do you talk to your code repository. And then once you create this, in fact, right now what we are seeing is all the questions are disconnected. You can also make it like a chatbot as well. You ask one question, let's say if you are getting the wrong answer, then you can import, you can include the memory component. After the memory component inclusion, you can also ask the connected questions to the previous question. In fact, the memory is the next topic that we are going to discuss. But as of now, RAG is the topic that we have discussed, and this is the assignment for RAG. Make sure that you complete this assignment thoroughly, and then only you move on to the next topic of discussion. I'll see you in the next video.